Hello everyone, I am Ibrahim Pathan Sakib. Welcome to my presentation. Today my presentation topic is application of nanomaterials for the separation of organic pollutants. Let's start. At first, we have to understand what are nanoparticles. Nanoparticles are defined as those particles that have at least one dimension in the nanoscale range, that is about 1 and 100 nanometers. Here, I have tried to show a picture for the comparison of size of nanoparticles with the size of other particles. If you look at the picture, we can see the size of the coin is about 10 to the minus 2 meter, and the hair is about 10 to the minus 4 meter, and the size of virus is about 10 to the minus 6 meter. But if you look here, the size of gold nanoparticle is 10 to the minus 8 meter. So we can see that the nanoparticle size is about very small compared to the other particles. Why we should use nanoparticles for the separation process? There are some unique characteristics of nanoparticles so that we can use them for the separation process. These are high surface area, magnetic behavior, stability and reusability, and reactivity. Nanoparticles have very high surface area to volume ratio, so they are highly efficient for the adsorption of organic pollutants. Magnetic behavior. Magnetic nanoparticles such as iron oxides are efficiently used for the magnetic separation of nanoparticles of organic pollutants. Nanoparticles are highly stable, so they can be reused for the separation process. And last one is reactivity. We know the nanoparticles are extremely reactive, so they can be efficiently used for the catalytic degradation of organic pollutants. Classification of nanoparticles. Nanoparticles are classified based on their nature. They are categorized into three categories. The first one is organic nanoparticle, the second is inorganic nanoparticle, and the third is carbon-based nanoparticle. What are organic nanoparticles? Organic nanoparticles are those nanoparticles which are biodegradable, non-toxic. These are extremely sensitive to thermal and electromagnetic radiation. Examples of organic nanoparticles are dendrimers, liposome, micelles, and ferritin. What are inorganic nanoparticles? Inorganic nanoparticles are those nanoparticles which have characteristics. For example, they have crystalline structure, they have surface charge and surface density. Examples are metals, for example, silver, copper, gold, aluminum, and metal oxide, for example, copper oxide, zinc oxide, and iron 3 oxide. What are carbon-based nanoparticles? Carbon-based nanoparticles are those nanoparticles which are made up of carbon nanotubes only. For example, fullerenes, graphene, and carbon nanotubes, etc. Coming to next is classification based on their dimension. Based on the dimension, nanoparticles are classified into four categories. These are 0-dimensional nanoparticle, 1-dimensional nanoparticle, 2-dimensional nanoparticle, and 3-dimensional nanoparticle. 0-dimensional nanoparticles, for examples, are carbon dot, fullerene. 1-dimensional nanoparticles are nanorods, nanofibers, and 2-dimensional nanoparticles are graphene and coated nanoparticles. And the examples of 3-dimensional nanoparticles are polycrystal, dendrimers, and nanosphere. There are a variety of applications of nanoparticles. They are used in nanomedicine, they are used in environment, they are used in agriculture, and they are also used in consumer goods. In nanomedicine, nanoparticles are used for the targeted drug delivery. They are also used in drug delivery, they are used in gene therapy and in cancer therapy. In environment, they are used for the application of the removal of toxic pollutants, and they possess catalytic activity. In agriculture, they are used for cell leveling, fertilizer delivery, and in consumer goods, they are used for cosmetics and fast moving electronics, nanoelectronics. My topic also include organic pollutants. What are organic pollutants? Organic pollutants are also called persistent organic pollutants, that are POPs. Persistent organic pollutants are those group of toxic pollutants which resist environmental degradation. That means they can persist in the environment for a long period of time. Now, what are the sources of persistent organic pollutants? The compounds coming from volcanic activities and forest fires. The examples are dioxins and dibenzenofurands. POPs may also come from chemicals used in industry, byproducts of industrial process, chemicals used in agriculture, pesticides. The examples of POPs from chemical industries are fluorinated compounds, hexachlorobenzene, and polychlorobiphenyls. And byproducts of industrial process are dioxins and furans. And the pesticides used are DDT, eldarine, etc. Nanoparticles are also used for the application of in the treatment of wastewater. They are used for the separation of inorganic pollutants such as nitrates, inorganic anions, chlorinated compounds, and radio elements, and they are also used for the separation of organic pollutants such as phenols, organic dyes, and nitroaramid compounds. Here, I have given a mechanism for the photocatalysis to decompose organic molecules. Let's look at how this mechanism works. Here, I have shown a mechanism of photocatalysis for the decomposition of organic molecules. Let's look at how this mechanism works. When light energy is radiated on the surface of a nanoparticle, titanium dioxide, electrons are released from the surface, and these released electrons are absorbed by organic molecules, oxygen, and to form superoxide anions. And the surface of titanium dioxide becomes positively charged. And that's why they absorb electrons from moisture in the air, and the moisture in the air becomes hydroxyl radicals. These hydroxyl radicals then combines with superoxide anion and organic substances to convert them into less harmful carbon dioxide and water molecules through oxidation and reduction process. The next topic is nanofiltration. For the nanofiltration, we have to prepare OHM sponges. What is OHM sponges? That is oleophilic hydrophobic magnetic sponges. For the separation of organic pollutants, oil from the oil water mixture, when there is a linkage of oil, we have to dip the sponge into the oil water mixture. The sponge has a nanocomposite coating of carbon substrate. When we dip the OHM into the oil water mixture, the sponge sufficiently absorbs all of the oil, leaving behind the clean water because of its hydrophobic nature, that means water resisting property. For the recovery of oil, we have to squeeze the sponge to get the oil, and then we can reuse the sponge for separation process again. The next is nanoadsorption. Here I have shown a nanoplastic and how nanoplastic works for the separation of organic pollutants. Nanoplastics are functionalized with specific functional groups, for example, hydrogen functional group and carboxyl functional group for the separation of organic pollutants. These functionalized nanoparticles can be dispersed into water for selectively removal of organic pollutants. Here, the nanoplastics sufficiently absorbs the 2,3 phenyl diacetate through pi-pi interaction, and the surface of nanoplastics have hydrogen functional group as well as carboxyl functional groups, so they can form hydrogen bond with the organic pollutants and sufficiently absorb all the organic pollutants. The next one is uncharged molecules of persistent organic pollutants. They absorb the uncharged molecules of POPs through Van der Waals forces, and also the charged molecules of POPs through electrostatic interaction. The molecule of anthracene are absorbed onto the surface of nanoplastics through hydrophobic partitioning. So in this way, we can sufficiently remove the organic pollutants from water. Thank you all for having some patience.